In this video, I will talk about instrumental variables in R. Before you watch this video, please make sure that you have watched my other video called Instrumental Variables. I have opened up the R script here. I have downloaded the data, MROZ. I have put it into the directory here, and I have run the program, and the results are shown in the console window, which is typically below here, the R script, and I have put it to the side. So what we're going to talk today about is instrumental. So what we are going to talk today about is IV estimation, instrumental variable estimation, the two-stage least squares procedure when we have a simple linear regression, multiple linear regression with multiple instruments, and then we will test for endogeneity. So here are a few required packages that we're going to be using here for this R script. And as I said, we're going to be reading the MROZ.csv data file and calling it our data frame MROZ. So this is a data set of working women, and in labor force is one of the variables in there, and we will filter and only keep working women. So if in labor force equals 1, then we are going to keep only those observations in here. So now let's, from this data frame, select the variables log wage, education experience, experience square, father's education, and mother's education, and use Stargazer to summarize the data and then look into the first 10 observations of the data set. So here's the data set that we have here, and this is data for only working women. And we're looking at the first 10 observations. Here's the log wage for them. This is the number of years of education, the number of years of experience, experience square, and this is the number of years of the father's education and the mother's education. So now we are suspecting that education is an endogenous variable that is correlated with the error term, and therefore we would be using father's education and mother's education as instruments for education. And here, more observations for the rest of the data. And here we have the means of each of these variables. So again, the education for a person is 12 years on average, and the father's education is 9 years on average, and this is 9.5 years on average for the mother's education. Okay, so now let's start with running a simple linear regression model. And here we would be using linear model, log of wage being our dependent variable, education being our independent variable. And let's summarize these results here in model 1, and then pick up and store the coefficient from model 1 on education. So what we're getting here is the following results. We have the coefficient on education here is 0.10. So this is the regression of log of wage on education. So the way to interpret this coefficient here is that for each additional year of education, we have 10% lower wages for women. Now, we are suspecting that education is endogenous, meaning correlated with the error term, and that here this coefficient may be biased. So in order for us to correct for endogeneity, we would be using instruments here. So let's discuss the instrumental variable estimation. So here we have the dependent variable would be y, the endogenous variable would be x, and the instrument z, which is not correlated with the error term, is going to be denoted as z. So we have two formulas. One is for the coefficient of using the all less method, and the other one is for the coefficient using the IV method. So here we have the summation of x minus x bar, y minus y bar, divided by the summation of x minus x bar times x minus x bar. So this is the formula for OLS that we have. The formula for IV is going to be Z is going to be replacing X in this formula here, and also in this expression right here. And here we would be having X bar. So it's almost similar to the formula as OLS, but here we would need to replace X with Z with the instrument. And so let's use these two formulas to calculate the coefficients using the OLS method and the IV method. So the first thing that we need to do is calculate the means. And so to do that, let's first attach the data so that the variable names can be used directly. And here we would be calculating the mean of father's education, mean of education, and mean of log of wage so that we can use in the data above. So here we would have that father's education would be an instrument for the endogenous variable education, and this is our dependent variable y. So this is y, and this is x, and this is z in this case. So let's calculate the OLS coefficient. So to do that, we're going to have to do education minus mean education times log of wage minus mean of log of wage. And then education minus mean education times education minus mean education. So basically, I'm replacing here this formula where y is log of wage and x is education, and then I'm summing these up expression and then dividing them, and this is going to be the coefficient using the OLS method. Now for the coefficient using the IV estimation method, here the way to form the numerator is we have z minus the z bar, and here we have y minus y bar. You see this formula up here. And then on the bottom, we have z minus z bar, and here we have x minus x bar. So then we're going to sum up and divide these expressions to get the coefficient using the IV method. And so here are the coefficients. So we have 0.10. So notice that this coefficient 0.10 for the OLS is exactly the same as this coefficient here that we had on the OLS model. And the coefficient for using the IV method is 0.059. So the way to interpret this coefficient is that for each additional year of education, we have now wages that are 4.9% higher than before. So using instrumental variables method, we're showing that we actually have a much lower effect of education on wages than using the OLS method that ignores any potential endogeneity issues of the regressors. So again, lower effect in this particular case using IV method than the OLS method. So now let's look at the two-stage least squares estimation, and we would be looking into a simple regression model that we have one instrument. So here for the OLS estimation, let's go ahead and first summarize model 1. And this is the model 1 that we have here. And again, we see that if the model is log of wage, regressed on education, and we're ignoring the endogeneity issue, we have that the coefficient here is 0.10 on education. So how do we do two-stage least squares? So two-stage least squares, we're going to use the IV reg. Formula would be log of wage regressed on education. And here we would have to say for the first stage, which ones are going to be the instruments. So here we are saying let's not use education because it's the endogenous variable, so we're subtracting it, but we are going to be adding father's education in here. And so this is going to be for the first stage least squares. And then we're going to be using this data set. And then we are going to use to summarize this model through 2, which would be the two-stage least squares. And then for diagnostics equals true, we're going to be looking at a few at other things that are going to be listed in the output. So what we are going to see here is that in the two-stage least squares, this is again the IV reg that we're going to be estimating. Here is now the estimated coefficient that is shown to us, and that is 0.059. And if you notice before, this is exactly the same coefficient that we actually estimated manually using the IV method above. We have received uh, the same coefficient here before. So again, the first stage of these two-stage least squares was when we had education regressed on father's education. We got the predicted values from this, and this here, instead of education, we use the predicted values of education to get to this coefficient here. So while this is not showing here as education hat, that's what we have here. These are the predicted values from the first stage least squares to obtain this coefficient here. These are the diagnostic tests that we actually have included here if you're interested in seeing those as well. So this is the easiest way to do a two-stage least squares is to just use the IV reg. Now, we can do it the slow way, which is we can estimate the first stage of the two-stage least squares. And for this, we need to regress the endogenous variable education on the instrument of father's education. And this is going to be the equation that we're going to be estimated. Education regressed on father's education. And this is the results that we're going to be getting for the first stage of the two-stage least squares. Education is regressed on father's education. And here we would have, this is being the coefficient here on father's education, 0.26. And we can also note that the R square from this regression is 0.17. So this is the first stage. So here we can also display the R square from this model. So now we need to get the predicted values education hat, and the predicted values would be education hat. We would be picking up the fitted values from this model 3. So the fitted values from this model, that would be education hat. That's what we're going to call it. And now let's go ahead and just compare education with education hat and see what we get. So from the data set, we're going to be looking at education, father's education, and education hat. And then let's look at the first 10 observations. So this is how these predicted values look like. So this is education, this is the endogenous variable, and this is the instrument of father's education. So when we regress education on father's education, we actually get this equation here. And so now we can actually predict the education hat using this regression here, and this was going to be education hat. So notice now that this education hat that we have here is only based on the father's education. So if the father's education is 7, these are the values. If it's 14, these are the values. If it's 3, these are the values. So we can also say that this education hat contains only exogenous information from father's education because father's education is not correlated with the error term. So if there's any endogeneity, we now left it in the error term, and it's not here. So any endogeneity again is in the error term or in the residual. But this predicted value contains only exogenous information, and this is why we can use it later on. So for the next step, this was the first stage of the two-stage least squares where we regress the endogenous variable on the instrument. We pick up the fitted value, education hat, and now for the second stage, we regress log of wage, which is our dependent variable, on education hat. These are the fitted values from the first step of the two-stage least squares. And when we summarize this model, this is the coefficients that we get here. So we have this coefficient of 0.059. So notice this is exactly the same coefficient that we obtained here with this model, doing it the fast way, as well as using the IV method that we had in the previous section. So notice that this coefficient here is not significant at the 10% though. So when we're actually, another important point to mention here is that these coefficients here are correct, but the standard errors are not correct when we do a two-stage least squares like that. And so these standard errors would also need to be corrected. So the one advantage of using the canned package here for running an IV reg is that these standard errors here are corrected. So even though the coefficient is the same, the standard errors are corrected. And here we have that this coefficient is actually significant at the 10%. And so we should really be using the IV reg in order for us to do two-stage least squares and not do it the slow way here that I've shown you, because the standard errors are not correct using getting it done the slow way. So now let's talk about two-stage least squares when we have a multiple regression model with several independent variables and two instruments. So for this, let's go ahead and estimate the model of log of wage regressed on education, experience, and experience square. So let's assume that these are exogenous variable and only education is endogenous. So if we want to run a two-stage least squares estimation, we would be using the IV reg, and here we would be pointing to the main equation. And here what we're saying for the first stage is that we're going to be subtracting education because it's endogenous, but we're going to be adding two instruments, father's education and mother's education here. And that's going to be the first stage least squares. And then let's summarize this. Let's summarize this model. Okay, so here is the results that we have here. So if we're looking into just an OLS estimation, we would be getting the results using obviously the OLS method. But here we would be having the two-stage least squares results. And this coefficient now here would be the coefficient on education would be 0.06. So basically, the way we would interpret it is that each additional year of education would bring in 6% higher wages. And this is a coefficient that is estimated after we have corrected for the endogeneity. So again, we can do it the slow way using two-stage least squares. So in the first stage, we would be regressing the endogenous variable education on the instruments of father's education and mother's education. And these would be the results here. So this is the first stage results. So notice that the endogenous variable is regressed on all of the other exogenous variables plus the two instruments. So anything that's exogenous, we keep it in this first stage and we add the instruments here. And these are the estimated coefficients that we have, which are not very much of interest, but we can test here whether education and father's education are correlated. And for this, we are going to be using, from the package CAR, we are going to be using linear hypothesis. We're going to be giving model 7 results here, model 7, and here we would be testing whether the coefficient of father's education and mother's education are significantly different from 0. So if you're looking at them individually, we actually have that the coefficients are individually significantly different from 0. But using a joint test, we're looking at the p-value here, and that's less than 0.05. So basically, these two coefficients are also jointly significantly different from 0. So actually what we are finding here is that father's education and mother's education are good instruments that are correlated with education. So that's an important thing here to mention. Okay, so moving on, what we're going to be doing next is getting the predicted values for education hat, predicted values for education, which we would call education hat 1. And so these are the fitted values from model 7 that we estimated up here. So these are the fitted values. That's this education hat. We're going to call it education hat 1 to distinguish from the previous education hat that we had. And then here, for the second stage of the two-stage least squares, we have exactly the same equation that we had above here. However, we are going to be replacing education with education hat. And so these are going to be the results again here. And as you notice, this is exactly the same coefficient that we had before using the IV reg. However, again, these standard errors are not correct. They need to be corrected when we use the two-stage least squares. So this actually is appropriately corrected for the standard errors using the IV reg. So when you do a two-stage least squares, always use the IV reg instead of the slow approach. But I just wanted to show you how to think about going to derive these two-stage least squares estimates here. Okay, so the final thing that we're going to be doing here is testing for endogeneity, and we want to know if a variable is endogenous before applying the two-stage least squares procedure. And so here, let's go ahead with looking at the Model 5. And Model 5 was the log of wage regressed on education, experience, and experience square. So these are the coefficients that we have here. And what we want to do is, this is now what we are going to be calling the structural model. The reduced form equation for regression would be basically the first stage of the two-stage least squares, where we're going to have the endogenous variable regressed on all of the exogenous variables from the model above, plus the instruments. And this is going to be the summary for this model that we have here. So that's going to be the model that we have here. So now remember that in order for us to do the two-stage least squares, what we're doing is we're picking up education hat, which is the fitted values from this model, because they only contain the exogenous information from variables that are exogenous and also from instruments, which are also exogenous. So now, if instead of doing education hat, the fitted values, if instead we're looking at the residuals in this model, and call this V hat, these residuals are actually going to contain potentially the endogenous information that is being left behind. And so now that we have these residuals, what we can do is we can use the same structural model that we have. This is the original model that we had above. And we can include these. So dot plus v hat, we're going to be including this residual in this model. And let's look at this model. So this is the model that we had before, and here is these residuals V hat that potentially include the endogenous information that are now included. And what we are interested in is whether or not this coefficient is significant. And here I'm seeing a significance at the 10%. And so here the null hypothesis would be that the coefficient on the residual is not significantly different from 0, which would mean exogeneity. And if this coefficient is significantly different from 0, we would have endogeneity. So in this case, we have here this coefficient is significant at the 10% level, if we look at the p-value. So our conclusion here is that the coefficient on the residual is significant, so education is endogenous, and we do need to use the two-stage least squares to correct for this endogeneity. Okay, so again, I have shown you two different ways of calculating of correcting for endogeneity. And first one is to use the IV method to calculate the coefficients. And then we talked about the two-stage least squares procedure for estimating a model when we have endogenous independent variables, and finally we tested for endogeneity. So this concludes the presentation on instrumental variables in R. Thanks for watching.